Hello friends, welcome to my channel Scientist Words. I'm your friend Ashwin. Today we're going to talk about cosmic collision, the mind-blowing origin story of Earth's moon in this video. Welcome lunar enthusiast. Today we are diving into one of the most fascinating mysteries in planetary science. How did Earth get its moon? This isn't just a tale of celestial bodies, it's a story of cosmic violence, planetary evolution, and the various conditions that made life on Earth possible. From early capture theories to the modern giant impact hypothesis, our understanding of the moon's origin has evolved dramatically. So let's take a journey back in time, about 4.5 billion years, to witness the spectacular birth of our celestial companion. Before we get to our current best theory, let's look at some early ideas about lunar formation. The capture theory suggested that the moon formed elsewhere and was later captured by Earth's gravity, like a cosmic game of catch. The co-formation theory proposed that the Earth and moon formed together from the same cloud of dust and gas. And the fission theory, famously proposed by Charles Darwin's son, suggested that the moon spun off from a rapidly rotating early Earth. While each of these theories had merits, they all faced significant problems when confronted with the evidence. It's like trying to solve a cosmic jigsaw puzzle, but the pieces just wouldn't fit. Even the giant impact hypothesis, our current best theory for lunar formation. Picture this: about 4.5 billion years ago, a Mars-sized object, let's call it Theia, slams into the young Earth. This wasn't just a fender bender, it was a collision of planetary proportions. The impact vaporized Theia and blasted part of the Earth's mantle into space, creating a ring of debris around our planet. Over time, this debris coalesced to form a moon. It's like Earth had a bad day at the cosmic dodgeball, but ended up with a new best friend. This theory elegantly explains many of the moon's unique features and has become the leading model for lunar formation. So, what evidence supports this cosmic collision theory? First, moon rocks and Earth rocks have strikingly similar isotope ratios, suggesting they are made of the same stuff, but the moon lacks a large iron core like Earth's, consisting with the formation from the mantles of Earth and Theia. The angular momentum of the Earth-Moon system also matches what you expect from such an impact. It's like cosmic forensics piecing together cues from a crime scene billions of years old. Each new piece of evidence, from lunar samples to computer simulations, has strengthened the case for the giant impact hypothesis. But the story doesn't end there. Recent research have been refining and sometimes challenging aspects of the giant impact theory. Some models suggest a much more energetic collision that would have vaporized both the impactor and much of Earth. Others propose multiple impacts rather than a giant single one. There is even a theory the Earth and the Moon formed from a structure called synesthesia, a donut-shaped cloud of vaporized rock. It's like watching a cold case being reopened with a new forensic techniques. These ongoing debates show that planetary science is a dynamic field, constantly evolving with new data and ideas. The moon isn't just a pretty face in the night sky, it plays a crucial role in making Earth habitable. It helps stabilize Earth's axial tilt, preventing wild climate swings that could have made life difficult or impossible. The moon's gravity also creates tidal forces, which have shaped Earth's coastlines, influencing the evolution of tidal organisms, and may have even played a role in life transition from sea to land. It's like having a cosmic stabilizer wheel on a planetary bicycle. Understanding the moon's formation gives us insight into the unique conditions that made Earth such a special place in our solar system. The quest to understand lunar formation is far from over. Future missions to the moon, like NASA's Artemis program, could provide new samples and data to test our theories. Scientists are also searching for traces of the ancient impact, like particular isotopes or minerals that could only have formed under those extreme conditions. And this isn't just about Earth and Moon. Understanding how our satellite formed helped us model how exoplanets and their moons might form around other stars. It's like using the moon as a Rosetta Stone to decode the history of a planetary formation throughout the universe. And there you have it, the epic tale of how Earth got its moon. From a violent cosmic collision to the graceful dance we saw today, the story of lunar formation is a testament to dynamic and other chaotic nature of planetary evolution. The moon is more than just our nighttime companion. It's a crucial part of what makes Earth unique and habitable. As we continue to refine our understanding of lunar formation, we are not just learning about a single event in the past, we are uncovering the processes that shape planetary systems throughout the universe. So the next time you look up at the moon, remember you are seeing the aftermath of one of the most important events in Earth's history, a cosmic collision that helped made our world what it is today. The moon isn't just a satellite, it's a part of Earth's own origin story written in the sky for all to see. Thank you very much for watching this video. I hope you enjoyed exploring Cosmic Collision, the mind-blowing origin story of Earth's moon. The moon's dramatic past continues to reveal secrets about our solar system. Stay curious and keep exploring the wonders of space. Thank you very much for watching. See you guys in my next video. Thanks again. Bye bye.